All right, day one we looked at simplifying, multiplying, and dividing rational expressions. Today we are going to be dealing with adding and subtracting rational expressions. We're actually going to spend 3 days on this topic. These are the 6 steps that will get you through all 3 of these days. However, we break each of these days down into just focusing on one piece or just a smaller piece of it. Today, we really will only be looking at these 3 steps. Some of the problems, you'll be able to factor the numerators at the end, but a good chunk of them, we're just going to be stating the domain, getting our fractions to be common denominators, and then just adding them together. So here's 2 examples, and these are the examples where we do have common denominators. So we need to combine the rational functions and state the domain. One thing you need to remember, when you're adding fractions, I'm only able to add together fractions with common denominators. So like 1/2 plus 3/2 is 4/2, which is eventually 2. One thing you're not able to do is I can't add 2/3 to 1/2, not easily. I have to change my denominators to match them so that all I have to do is add up my numerators. So as you see here, my denominator for both is x plus 3. So from there, all I need to do is actually add together my numerators. So my denominator doesn't change. But when I go to add my numerators, I just combine like terms. So I have 3x plus 2x is 5x, and -4 plus 5 is 1. I need to state the domain. So remember, the domain is my denominator could never equal 0. So when I solve for x, this tells me that the value -3 would make this rational function unsolvable or just unusable. 5x plus 1 over x plus 3, that won't simplify down at all. So this is my final answer. For the second problem, as you see here, the difference is this is a subtraction problem. What I want to do, I still have common denominators, so I know it's going to combine to 2x minus 6 on the bottom, but because I'm subtracting, you notice how there's 2 terms to the right side. I want to change this to an addition problem. So it's kind of like how we change the division problems to multiplication. I'm going to change this to an addition problem, and what that means I have to do is I just need to change the sign in front of both of my terms. So you see I put a red line above each number. It's supposed to be a negative in front of each number. Sorry, my pen doesn't have the best accuracy. But then from here, it's the same thing. This -5x doesn't have a like term, so that just stays out front. But then I have 11, and I'm combining it with -1. So 11 minus 1 is actually positive 10. One thing you want to look at, -5x plus 10 and 2x minus 6, they actually both have greatest common factors. So if you can factor it, you always want to look out for that. So if I factor out a -5 on the top, I'm left with x minus 2. And if I factor out a 2 on the bottom, I'm left with x minus 3. Now this doesn't give me anything to cancel, but it does actually make finding my domain easier. So if I have 2 and x minus 3 at the bottom, that means my domain is that x could never equal positive 3, because sticking a positive 3 down there wouldn't give me a problem where I'm dividing by 0. So that's what you need to do if you have common denominators. Now, if your denominators are not alike, as you see here, I have d for my first denominator and 4 for my second. What you need to do to get common denominators is you're just going to multiply in what's missing. So if my first denominator has a d in it, that means my second denominator also needs to have a d in it. So I have to multiply d to top and bottom. Since my second denominator has a 4 in it, I need my first one to have a 4 in it as well. So I'm going to multiply 4 to both the top and bottom. So that gives me 24 over 4d minus 3d over 4d. Because now what you notice is I have common denominators. Since it's subtraction, I'm just going to get in the habit of changing it to an addition. And when I combine this, I'm always going to put my variable in front. So I'll do negative 3d plus 24 all over 4d. Again, I notice that negative 3d and 24 have a number in common, so I'm going to take out the GCF. So that's negative 3, which leaves me with d minus 8 all over 4d. Again, that doesn't help cancel anything, but you always have to check. My domain here is that x cannot equal 0. So with problems this week, or problems for today, you might just see where you have to multiply something into both fractions to get your denominators to match. We're actually going to save this second example for class. I just want you to really take time to understand what was happening here, and then we can apply that to more problems in class. So this is actually going to be your try on your own. Again, let's save this one for class time, which means you just need to follow this example. And as you notice, this example does have two common denominators. So you want to look at the examples on the first page, so examples 1 and 2. Follow those steps, combine, notice it's a subtraction problem, so remember what I said about how to subtract. Otherwise, just combine your numerators and see if you can factor at the end and state the domain. Good luck, see you in class.